All right, so we'll get started. I'm sure a few more people will join while I'll do the quick intro. So many people already know that HP Dev introduction, so they want to skip that. So thanks for joining. My name is Didier. I'm the tech lead for the HP developer community. We have a group of panelists today. Very excited to run this session. I will hand over to Audrey as a master of ceremony first, and before I do that, I will just quickly introduce some of the things we do at the HP developer community, and then we'll kick in the session of today, which is exploring transformative AI use cases across industries. We'll try to make this as interactive as possible, so please use the chat. There's a chat button for starting discussions, and there's also a Q&A button that you can start to ask for more questions, and we have enough panelists today to answer all your questions. So let me get started with just a couple of slides. First of all, I would like to say that this Munch and Learn series has been running for almost 3 years now on a monthly basis. And we know we have users that are coming every month, so thanks a lot. We have a session planned for September, which is actually a postponed session from July. We had an issue with the speaker in late July. So we're running that session again in September. So mark this in your calendar if you're interested. That's going to be September 18. The Munch and Learn series is really about thought leadership. It's not really about product. It's very vendor and product agnostic. We're trying to talk about technology trends, and trying to give good advices. We have another series called the Meetups. These go into more details. They are typically open source or product technology or developer technologies that you might be interested in. So we have a couple of sessions already planned. The August session is at the end of the month. Meetups are always the last Wednesday of every month. So we have a session on fine-tuning for large language modules. And this is handled by a team of speakers from the Determine AI group. That should be really good. We have this already open for registration. And I know my colleague Denis will put the links in the Q&A. And then we have September and October. We don't have yet fully final titles, but the one for September will be on the Sustainability Insight Center. And the one for October would be on the eventing framework for GreenLake. So stay tuned for this to show up in our meetup page, where we have all the links for registering. Same thing for Munch and Learn. In addition to that, these two pages have replays of all the sessions we've run in the past, which we make available on YouTube on our channel. This session is also recorded, and we'll make it available in the same place. The link will be available on the Munch and Learn page. So this is for the webinars, but running a developer community is really about getting this community active. We have a number of things to get people to learn new technologies. One of them is what we call the workshops on demand. You can give this a try, and if you go to that URL, we have more than 30 workshops in our catalog. We use a Jupyter Notebook experience. It's available 24/7 over the internet, and it's free. So give it a try, and if you do, provide us with feedback. What's missing, what worked, what didn't work. And that's always helpful for getting new things in the catalog. And as I said, this is a community, so we need people to contribute or participate. If you like these talks, don't hesitate to invite others to join the talks. It's open to everyone, customers, partners, and of course, HP employees. We have a newsletter that we send every month that you can also sign up to, so that you don't miss anything that was released during a month. This is where we advertise our talks, and this is also where we advertise our latest blogs. We have a dedicated Slack workspace for HP Dev that you can join. And this is a great way to help the community ask questions, but also help answering questions. So give it a try. Finally, we have a Twitter/X account called HP_developer that you can follow. And if you're a subject matter expert, we would like you to help us create new content. So You can write a blog, for example, to discuss some of the technology you're already an expert in. And we have a complete explanation of how to join and how to write a blog. We use an open source content management system, so it's pretty easy to contribute. You can also reach out to us or to me for delivering meetups or participating in events such as HP Discover. And finally, if you think we're missing something in our workshop on demand catalog, then again, reach out to us and we can maybe work together. We have a framework. You can just plug an additional workshop. These are all the links to get to us in the different ways. We also have an internal Slack for the internal HP folks in the room that you can join. And with that, I will hand over to Audrey for the rest of the content. Thank you very much.
All right, well, welcome everybody. I think we've got the name down. So let me dive right into what we're going to be talking about today. So we're going to start with some AI use cases in the enterprise, and then we're going to go into a developer perspective on these AI experiences, and then how you could measure the future state. So our speakers today have been involved with the architecture, engineering, and adoption of AI solutions. And it's really just no surprise to all of us here today that AI is transforming industries and that we're really just at the beginning of this phase. And although the hype doesn't really help with all of you trying to be hands-on keyboard and solve real business problems. And so that probably just adds pressure, right? And so our panelists are here to bring you some real use cases and considerations for getting started, and also to share how HPE is adopting AI and dive into some of these best practices that we have. So I'm going to let everyone go ahead and introduce themselves, and we'll start with Travis.
Hi, I'm Travis Tripp. I am on the Chief Architect team for the HPE GreenLake platform. And for me, in my role, one of the interesting parts is I get a little bit of visibility across sort of all of the things that HPE is doing in the GreenLake space with AI use cases. And it's just interesting to see that as they all come together, how we can really create better use cases for all of our customers as we bring it together on GreenLake.
Hi, everyone.
Thanks,
Peter
Travis.
Moser. I focus a lot on solutioning, mostly around hybrid cloud, data AI, digital twin. Most of the industries that I focus on: manufacturing, oil and gas, energy, some transportation, and then again on the smart city side.
And I think, and Anthony, I'm not sure if you're
I just promoted you to
there we
panelist.
go. Okay.
Hi, Audrey. Hi, everyone. Can you hear me okay now, Audrey?
Yes, we can hear you.
Hi, everyone. Anthony Delicali. I'm a technology strategist and go-to-market lead within our office of the CTO. I have the honor to have conversations, mostly innovation conversations, with many of our enterprise customers on a daily basis, where clearly this topic this topic being AI, and specifically generative AI, is top of mind and top of priority with many of our enterprise customers. Look forward to today's active dialogue.
And we'll go to Mark.
Yeah, hi, I'm Mark Pereira, and I'm a lead developer in the Office of CTO in an innovation team. We incubate and kind of look at new innovative technologies. As we get through kind of the session unfolds, I'll talk about some of the projects and things we've worked on, some of the technologies we looked at. AI is obviously a big part of what we do in terms of incubation and innovation technologies, and try to understand how those technologies can be incubated into product features or use cases within the organization, HPE organization.
Great, thank you, everyone. So let's get started. There's a potential of all kinds of use cases, from very specific, I would say, industry domain use cases that we see out there across finance and healthcare, manufacturing. And then we see some ubiquitous use cases like natural language processing, whether that's in call centers or healthcare transcripts. And so I want to turn it over to our panelists to dive into this a little bit deeper and share from your experiences if organizations are really discovering their own unique use cases based on the business need, or if there's common use cases that are emerging as a starting point.
Audrey, if I may, when I look at the audience survey, about probably 80–90% are early stage. And a lot of the customers I work with are early stage. That's about 80% of the market, by the way. So it's very representative of what I'm seeing in general. And really what they're doing is many are just trying to understand what's available, how does this work, and what can they do, like out of the box, if you will, commercially off the shelf, to solve some immediate business problems, because generally they don't have the skills, the staff, and sometimes the resources to do it on their own. And so then this is predominantly in manufacturing, retail, and in some healthcare, certainly on the smart city side.
Yeah, and I think in terms of kind of what I've seen working with various groups of people within HPE and being at HPE Discover and talking with people, the natural language side of this is a big part of generative AI. Being able to accept natural language, being able to respond in natural language is a major part of it. I would say another thing that is also a big part of what we're seeing is that a lot of knowledge that many times if you're doing an AI project, let me step back for a second. Many times you're doing an AI project, you have to start with a data source of some sort in order to build upon, use that as the foundation to build upon in that project. And many times that data source is a set of documents. It's either like it could be an IT ops use case where you have product documentation, or it could be a legal use case where you're talking about contracts. It starts with a set of documents. And a lot of times then people are trying to understand, how can I take that and turn it into something that's much more natural language focused? We'll start talking about some of the technologies as we go through the session, but I see that quite often, that a lot of times the source information is documentation, PDFs, things of that nature that need to work into an AI system with natural language kind of requests and responses.
I think that natural language is super key because everybody works with lots of different tools. They have tools that they worked with at their last job, at their new job. They bring in a new tool. And oftentimes you don't really know how to interact with that tool. You don't know how to query it, how to use it. And I think like one of the critical things of that natural language is being able to just go into any environment and just use it as a discovery engine. What can I even do here? Sometimes you can even ask, what can I even ask about this system?
I like that phrase, the discovery engine. I think it captures that ubiquitous natural language process of, I just need to ask a question.
The curiosity is absolutely there. I think, generative AI, when you look at ChatGPT and its onslaught onto the marketplace and rapid adoption, captured the imagination, the art of the possible with just about everybody. The thing that I see customers hitting the pause button is the guardrails. How can I make sure that this can deliver the answers I want it to deliver, and not something inappropriate, and that I can be able to maintain it over time. And I think understanding better how to use guardrails is one of the things a lot of customers are trying to figure out, because I think they're enamored with the possibilities of productivity and all sorts of customer experiences. But the pause button is, I need to have safeguards. I'm just not going to unleash this in front of my employees or my customers until I know I can be assured of the outcomes it's going to produce.
Audrey, I apologize. My camera is just not going to cooperate with me, so I'm gonna do this without my camera. I apologize to the team. Well, Peter, I couldn't agree with you more. We saw this a couple of years ago where a lot of customers were looking at modernization, and particularly data modernization, and one, trying to understand where their data was, and driving a lot of discovery type programs around where their data sits and how to best organize it. And now how do I best put it and deploy it, right? To Mark's point, it really starts with a set of documents and data sets that now I can start experimenting. How do I put governance around this before I start experimenting and learning? And then finally, I really like, Travis, your comment about, migrating to these new tool chains and tool sets, natural language processing being an example of that. The convergence in net new skills that are taking place now within our enterprise customers, as we look to find new budgets and migrate budgets to generative AI, I think is what's really fascinating here is how, as an industry, we're all upskilling now into these new tools chains to bring what is our current experience, whether it's engineering or a business background, into this brave new world and delivering on the promise of some of these use cases. I look forward to talking about not just the use cases themselves, but how we're converging on, skilling up, if you will, as an industry in tackling these new tools as well.
Yeah, I'll add to this too. One of the things that I think is sort of interesting in some of the projects that I've worked on is that generative AI in particular brings into sort of development a kind of a different concept of being able to test something and know like the quality of something you're working on. And that's something we'll again, I'll talk about more as we get into the session. But what's sort of interesting about generative AI in particular is if you're doing natural language questions and responses, I've worked many years of my life doing, projects around data manipulation, data management, those sorts of things. And it's interesting that testing in those type of systems was very black and white. Here, it's not so black and white, and the scope of questions that someone could have is not really known. You have to go through a certain kind of testing to see that you're actually getting good responses, quality responses. It's kind of a different way to approach this than you would a normal sort of data management project.
Yeah, that's a great point. Trying to decipher the quality of the output of some of these answers feels like grading papers sometimes.
Yeah, and I think most of us, when we first looked at ChatGPT and started playing with it, I mean, on the one hand, generative AI is incredible. Like it will answer questions and give you responses that are completely unexpected for a computer system to do. But then sometimes it will give you an answer that just seems disappointing. Like it's not exactly what you, so it can be kind of uneven, and the quality is definitely an issue.
I actually think so. I just was reading about a use case the other day of a drug company that is using generative AI to use some of what you're saying there, Mark, of like going out of the ordinary of what's unexpected to predict new ways that they can essentially combine compounds or chemicals and how they might react, right? And I think that sometimes, like when we're looking at, I need concrete hard data about, say, what this customer has said in the past versus I'm also trying to inject some aspect of creativity in what I'm doing to expand my horizon, right? So I don't stay locked in as a human being, which we tend to do. I think that based off of what you're doing with your AI use case, sometimes that creativity is good and sometimes it's extremely detrimental.
That's a great point.
For sure.
It's a really good example of a divergence from a typical use case that will be very specific depending on your industry or your application that you're looking to do. So we're going to, go ahead, Anthony. Sorry.
Hey, Mark, I loved your comment about, sort of how tolerant you are of some of the disappointing answers, right? Are we becoming less tolerant though, as we're seeing? There's a question from Michael from the audience as well. As we start building or trying to build sort of mission critical applications, are we less tolerant of how dangerous some of these hallucinations could look like? And as a developer, like how do you approach your tolerance now and being disappointed? I like that comment.
Right. Yeah, right. I mean, I think there's definitely strategies you can take, and we'll discuss as we kind of get deeper into this. Well, there's strategies you can take to guard against hallucinations. I mean, that is a big part of it, right? Sometimes you can go to just ChatGPT and play with it. And if you ask a complex enough question, it will answer. It's funny, like ChatGPT is sort of an interesting technology in that it will never say, I don't know. It will always answer. But it's like talking to your brother-in-law at Thanksgiving, always has an answer. Is the answer correct is the issue. And so it will be like, yeah, it will always answer, but the answer is not always correct. It'll hallucinate. There's strategies to take to safeguard against that. And there's also strategies to take to try to determine the quality of answers and whether those answers are valuable answers or answers that are going to be more quality oriented. There's strategies around all of that to make it better and stronger. But yeah, definitely when you develop these kinds of use cases, you have to take that into account. It's actually relatively straightforward to do a use case in which a natural language question harvests information off of like documents, let's say, and gives you an answer. It's harder to do that in a quality way so that the answers are quality answers. And I think without quality being really built into the equation, then a lot of what we're talking about is sort of not that useful. It's more experimentation than something someone could actually use. I mean, the way I talked about this is when we looked at like one of the projects I'll talk about is sort of a legal contract analysis. I mean, consider for a second, like if we were to do a traditional data-oriented project where we're doing something with a database and doing queries and whatnot, you would expect 100% sort of, correctness on queries. If you get to generative AI and you say something like, it will 90% of the time be correct. Okay, think about if I said to you, hey, your Outlook calendar will correctly deal with your appointments 90% of the time. You would say, well, wait a minute, what about the other 10%? Like, well, it could lose appointments, it could not notify you, it might drop 10% of your appointments, but 90% it will work okay. Then you would sort of start to say, well, wait a minute, don't I need to create a second calendar and sort of keep these things manually because I can't have a 10% failure rate of my calendar appointments. I can't miss 10% of my meetings and whatnot. So in AI, it's kind of like that sometimes. It's like if you're not careful, you can hit like a high percentage, but not high enough where someone can depend on it in their normal workflow, what they're doing. So you have to really get that number up to like 99%. That requires certain strategies to make sure that you're getting those kinds of responses.
That's a great point. It can have considerable impacts depending on what that use case is. 90 might fly in some scenarios, and 100% might be required in others.
Yeah.
Okay, so we're going to move on to some manufacturing and digital twin type of use cases. And Peter, I'm going to hand it over to you to dive into these use cases.
Audrey, if you could build out the slide. So
Sure.
one of the things that I'm seeing a lot in manufacturing, oil and gas, energy in particular, is this fusion of digital twin with AI. So this is actually, thank you, this is where the dots start coming together because typically these two domains have operated independent of each other. And so when you start looking at how do I go about, if you're a customer and you're going, okay, how do I go about transforming and digitizing my business? Like we'll just use manufacturing as an example. And so you have all this physical assets, buildings, equipment, and things like that. So now you want to digitize that, make a digital twin of it, which is taking something physical and making a digital representation of it. That could be a LiDAR scan, where it's just a 3D model of it, or it could be physics-based, right, where it has all the attributes of that physical asset, whatever it might be, a pump, motor, whatever it might be. So now you have customers saying, I want to be able to use digital twins in a lot of other ways and infuse AI in helping me better kind of do my modeling, predictive maintenance, reducing plant turnaround time, helping improve my worker productivity in the field, health and safety. And so this model here that you see kind of shows you all the different pieces you have to connect together to kind of create that outcome. Because as Mark rightly talked about, you got to kind of start looking at, okay, what insights are you looking for? Once you know that, then you got to start with, okay, where am I going to get the data to give me that insight? And so you start kind of working up. The next slide, please, Audrey. So you kind of work up the layers of a cake, right? You start working backwards into what the solution is going to look like based on the insight you want to get. Where does the data reside? How do you access that data? Then once you get that data, what's the quality of that data? You got to curate the data, make it usable. Then, okay, now that I have the data, what's the best model to use to give me the insight that I'm looking for? And how fast do I need the insight? And so this is where customers start missing things, because connectivity plays a big role in all of this, because that data typically is in bespoke locations like a sensor, a camera, something distributed somewhere. And now you need to collect data from it. And then if you have latency requirements, like say you need 15 millisecond or less response time, or something less than a minute, that network's going to really matter. And so then you start getting into the network connectivity piece. And then where do you need to do the inference or the prediction to get the insight because of latency reasons? So when you start looking at all the layers that need to come together to deliver the outcome, it's complex. Next slide, please. And so a lot of my customers, it really becomes a data lifecycle management problem, because typically most of my customers have no idea the data they have. It's voluminous. And then if they do have it, can they trust the data? Because a lot of people have data lakes. Well, data lakes have become data dumping grounds because there was nobody charged with maintaining the integrity of the lineage of the data in the data lake. So now they don't know if it's ground truth data or if it's been manipulated. So now they're going, how do I start getting trusted data, quality data, so I can even do anything with? And digital twins no different. You have LiDAR data, you have the physics data. How do you collect the data, then load it, index it, put your metadata tags on it so that you can then retrieve it? Then with digital twin, you have these very large image files that might be 100 gig. Well, you might have a whole plant or a factory or a drilling rig or a power generation plant or a tower if you're doing transmission. You'll have all these digital twins. So you have the macro view, then you want to be able to basically decimate it down into a pump or a motor, physical piece of that. And so managing data, being able to manipulate data through image, basically rendering, decimation, so you capture the data, you load it, you index it, you do your tagging. Now you've got it stored. You have your hot data tier where you're caching data for performance reasons. You have your cold data tier so you can be cost effective. Now you want to be able to retrieve it. And so this is where all the network connectivity and everything else and how you manage that data to be able to consume it out in the field on the consume side, because that's typically that last leg of the network is where the wheels come off the truck, because typically it's a 1 gig network and it's not well maintained, it's not reliable, sometimes it's not secure. And so how do you decimate the data on the digital twin where you can consume it on a tablet, a wearable, whatever it might, cell phone, whatever it needs to be? And then how do you preserve that ground truth data when in the field you're going to be taking field notes, maybe taking photographs, additional data to augment the original ground truth digital twin, be it LiDAR or physics based, that you need a digital thread to be able to move that data back, associate it with the original digital twin with the geospatial accuracy to know the exact association with that digital twin. So when I kind of walk you through that, this is kind of the data life cycle of a digital twin. Well, now think about taking data from those assets, the AI side, where you've got sensor data coming from the physical asset. You want to feed that into a digital twin. Next slide, please. You're starting to, there's a lot of data movement here. And there's a lot of data conditioning, and there's a lot of connective tissue you got to put together. So a lot of my customers, so hopefully you get an appreciation for the complexity here, but a lot of customers want a minimally viable solution. They want to know for risk mitigation purposes, can all this stuff be stitched together in my environment, which is critical, and can you show me that it's going to work And then also, one of the biggest obstacles in customer scaling is internal roadblocks, stakeholder buy-in. So this also provides a means for a lot of my customers to say, look, we've listened to you. We have workshops for this. We've listened to you, stakeholders. This is what's important to you. Let's do a minimally viable solution. That means the minimal amount needed to be able to prove this out, demonstrate it, but also be able to scale. Because now this becomes the foundation for which they're going to build their whole solution on. So they have to chuck it, throw it away. They want something that's going to be able to scale both in the digital twin, the AI side, the connectivity side, all the layers of the cake, so that when they prove it out, then their stakeholders, they get that buy-in, which is so hard to do, and they can get funding to then move it forward and do it more synergistically. Because everybody right now seems to be working in silos internally. You got this department or this business unit all doing their own thing, and they're not working together. So hopefully this little summary kind of gives you an idea of what a lot of my customers, the journey they're on. They're trying to mature their company to be more data AI driven, but at the same time internally have processes and governance and skill sets that limit their ability to change. And technology can do it, but the problem is internally you have to change also. Technology can't do it all. So hopefully this gives you an idea of what a lot of customers in manufacturing, oil and gas, power gen, and retail too, for that matter. These are the challenges that they're facing when trying to get on this AI journey, in the AI journey, not just natural language processing, which adds another layer of complexity with the guardrails. And so I'll kind of hand it back to Audrey, but this is literally, 10 different customers we're working with right now. This is all the path we're on.
I have Peter, this is Anthony. I have a question though. Look, the benefits of analytical AI, right, in terms of optimizing for process automation, especially manufacturing, is not net new. And we understand the benefits in delivering, ultimately cost savings, preventative maintenance being a critical use case. What's different, like the last 6 months to 12 months? What's different now with the new tools that are coming on board with the decision making to optimize these systems? Are you seeing, differences in either, time to value that's being measured differently, or different tool chains that, are easier to get proof of concepts up and running?
Anthony, that's an excellent question. And I'll share two real customer feedbacks that I've received. Is the answer is yes. The maturity of the technology in the last 18 months has been incredible. The coming together, the availability of models and Hugging Face and things like that. The GPU technologies, compute technology, storage. And I'll show you two value points of this driven customers. COVID really forced a lot of businesses to rethink their path of automation and accelerate it, because it disrupted their supply chain, it disrupted their labor force. And they said, you know what, this really hurt our business, and we need to be able to be more automated as much as we can to minimize any future impacts and disruptions. And because the technologies now have come up and matured to a point where they can use them, the customers of mine that are more mature, one customer with one use case generated about a 6-digit business value in 18 months. Another customer in about 3 years, an 8-digit business value. And they're just getting started. I mean, I know what their path is. It's a 10-year journey transforming an entire fully integrated oil and gas company. And they're very public about it. So I'm not divulging anything that's proprietary, but they've got an 8-digit business value with just the basics that they deployed. So to your point, Anthony, there is huge business value that can be achieved, but both these customers went about it in a very systemic way, building that foundation I was telling you about. And we're working with both of them to help them move forward more rapidly, because they're running into the internal challenges I talked about earlier.
Thanks, Peter, for that overview. It sounds like the digital twin is a really great example of where we see AI really stressing data management and data practices, like you're saying. And especially when they start having those conversations too of what something that's multimodal looks like, when you have sensor data, documentation, images, physics and pressure and heat, and all of these attributes starting to come in. It really looks at how do you create and mimic an entire system in order to control costs. And in order to do that, you need so many different points of data, not just one. So I love this digital twin use case. It really brings everything together in a hyper pressurized way.
It's definitely stretching the bounds of digital twin technology, just doing simulations. There's just, I'll give you an example. If you could reduce the turnaround time when you shut down a factory for maintenance, if you can reduce that turnaround time by just a few days, that could be millions and millions of dollars back up to the bottom line that would be lost otherwise. So the payback, the investment return on invested capital can be tremendous.
Mm-hmm. Yeah, there's a great example in our Doppler magazine from a colo in France, and how they use this digital twin to mimic something before they even build a certain wing of a data center. So even without even preventing necessarily, but just before you even start building or creating, you are optimizing. So you don't even need to go through the steps of having to redo something or the costs of re-architecting anything. So it's a really interesting way to prevent a lot of costs from the very beginning. Okay, so I'm going to turn it over now to Travis.
Yeah, sure. Thanks. So just wanted to talk a little bit about some of the areas that we're looking at AI of how to really make GreenLake better. And I said earlier, like I work on the platform, which if you think about it, I'm kind of in this middle green part and the things along the bottom. And what we have found is we have all of these sort of almost in some ways traditionally siloed use cases. So whether you're doing user management or the subscription, consumption, case management, and then you have to bring that together across the actual use cases that our customers really care about. So whether that's looking at their network correlation, looking at their compute, their servers, their storage, operating their workloads. And for us, one thing that we've realized is that what our customers really want is a unified search experience, or a unified way to query across all of these different use cases. And so if you go to I think there's a next slide, Aubrey. Yeah. Mm-hmm. So one thing that we've been actively working and building out is something that we're calling unified search, and it's really Gen AI based. And it's been a particularly interesting project for us, because when we look at this, the first thing that we had to do, and you see these on the slides, but the first thing we had to look at and say, well, what are some of our low-hanging fruit things that we can start helping our customers with? And for that actually turned out to be some of the things that, say, Mark was bringing up, like, hey, we have a lot of support documentation that's out there today, but sometimes it's hard to find and use that support documentation because you have to go over to another site, or maybe you have to already know what you're looking for. And so one of the ways that we started off with was actually getting all of that support documentation initially indexed, and then essentially asking our AI model, what are the questions I can ask about this, right? And so we put that together in a combined system that says, if I'm a new user and I'm just trying to discover GreenLake, I'm just trying to discover what I can even do, maybe I don't even know what to ask. So we had to think of a user interface that said, if you're using keywords, how might that be used to do like sort of instant traditional search? If you're using natural language, how can we translate that? Or if you really just want to even get prompts of the types of things you can ask, how can we present all of those up and then ultimately give you reliable results coming out of that? And that was sort of a baseline. And one thing that we're taking that now beyond is integrating it to other parts of GreenLake. So for example, Aruba, they've had AI search for a while that actually gets real-time data. OpsRamp, our correlation event AI ops-based system, they're building their own search. And so what we're looking at is how do we take this search and now essentially start creating a federated AI experience? And that then turns into, I can ask these questions, and based off the question, I can now look at that and say, who can answer that question? And then we can federate that out to sub AI engines, sub models, right? And get the right answers back. And a big part of this, is classifying the data. So first identifying, well, what is the data? What are the things that you can ask? The next is, how do I classify it so that what's the right technique to get that data? Sometimes the right technique is that you're taking data and you're putting it into, you're indexing it into some sort of a search engine or a vector database. Sometimes it's you're going to have to turn around and you're going to have to convert that query into API calls or SQL or some other query language to get dynamic real-time data back. And then on top of that, the part that's I've put most of my focus on, just because of the nature of my role, is how are we protecting the security of that? So a given user coming in, they have access to different data than other users. And so that means we have a whole section of having to understand not only what are you asking, where do I go to get the answer for that, but now when I retrieve the data or the result, what are the permissions that you have to see that result? And that requires both pre-query analysis, post-query analysis. And it's an incredibly interesting problem to have. And as we're building it out, it's really, to me, highlighted, and I answered this in one of the questions of how, it takes some really smart people to come up with the base sort of engine that can make this possible. And sometimes it's a smaller group of people that kind of start creating that. But then as we look at every single use case by use case and how do we put this together, it ends up itself becoming a federated problem of everybody figuring out, how can I securely get my data and what is the right way to expose my data into this system?
Yeah, Travis, I'm going to sound like a broken record. You're being bashful, right? You're an old search guy. You've been in search for some time. I know that.
Yeah.
So you have a domain knowledge and skill set, right? What's, per my question with Peter, what's different now? You get new tooling. I'm fascinated with how really smart people that may have a domain in one area are starting to upskill through this new tooling and recreating, that value proposition differently. Can you talk about what's different in today's state versus, when you started search,
Yeah.
2 years ago?
Old school search used to just be, let me get the data, let me convert it into maybe a JSON syntax for open search. Let me put that into open search. Let me tune maybe some keywords attached to this data, and then just throw some keywords at it. And then essentially open search, or people used to use Elasticsearch, it just looks at that and it says, okay, let me do some relevancy rankings of these keywords, right? And honestly, the beauty of old school search was it was super easy, right? Because it was actually also kind of stupid. It didn't really use intelligence. It used more of just maybe some statistical probability that the keywords that you've put in match the results that it's got indexed in sort of a generic and dumb way. The real difference here is, to me, is that we have to really consider, like I said, what's the right way to get this data, and how do I transform like what is static text documents, and I'm not just raw indexing them and throwing them into a search engine that's just looking at keywords, but what's the right way to pull those in? And is it best to do it statically? Is it best to do it, dynamically and augmented? What are the trade-offs there? Am I okay with some latency in a response in exchange for accuracy? or in exchange for security. And so the skills, you have to learn, you really have to, it goes beyond, I think Elasticsearch is just basic programmer stuff, turn it to JSON, load it here. But now you really have domain experts, and you have to have people that can help guide you. And what is the right way to do this? And ideally, what are people that can get you even the right tool chains and tool sets that are at your disposal? And that's where Mark really came in, honestly, with some of the prototype that I demonstrated at Discover, where we were looking at indexing our developer portal itself. So we were asking, how can I make an API call to do X thing, right? And so this is where we turned over to Mark, and maybe I'd let Mark talk a bit about this of some of the techniques used.
Yeah, I mean, I think one of the things that makes generative AI in particular seem like fantastic or seem just amazing is there's really kind of three aspects to it. One is in this particular problem, and several of the problems you'll see us talk about, is we do use retrieval augmented generation quite a bit. And that's because the underlying data source is a set of documents, and those documents could change. So it could mean that a API document or some kind of document, a product document, troubleshooting guide, that they can change on some regular basis. They could change like every 6 months or every 3 months or something like that. So you kind of have a moving data set that's constantly changing. So RAG is much better at dealing with changing out those pieces of data versus training an entire model and then having to retrain it as the underlying data set keeps shifting on you. So RAG is great in that particular case. And also RAG is also very good in that if you train something into a model, a large language model, you lose the connection of the actual source that trained. The source is generally going to be transformed into some kind of instruct data, and that instruct data is going to be used to train a model. Because you went through that whole transformation, you've lost the actual connection back to the document, back to the page number that generated all of this. So then when an LLM answers, you're not 100% sure always, is this a correct answer? Is this hallucination? In RAG, you're much more clear because when you generate that vector database in RAG, you're actually creating linkages back to the documents that generated it. So you have page level linkages, or you have per second linkage into a video. Video was transformed to text, text was transformed into a vector database, and then there's linkages back to that video of where that text came from to the per second in that video. So then someone then goes and does a search, and now you can not only give an answer, you can say, here's the links to the actual page numbers or video segments that I actually used to generate that answer. I think that's extremely useful so that in many of our use cases, someone can look at an answer and say, where did this come from? And I can show you exactly where it came from and take you directly to that data source. So then you can sort of follow up and say, okay, does this answer actually make sense? The second thing is, as opposed to search, these systems are conversational. The simplest way to understand conversational is you start talking about something, and then in follow-up questions, you refer to this or that. You don't have to re-explain the concept, but it's more complex than that. What's happening is the conversation, if you're doing drill down questions or follow-up questions, is being based on the previous questions and responses. So you're building an entire conversation with this language model in terms of its answers, which can be very powerful in drilling down to a particular issue. And then the third thing, and this is where it seems the most fantastic in terms of search is, but it works really well, is that in traditional search, each search is sort of an independent transaction. They're not conversational. And searching is a passive exercise. You're saying, I want to understand something. Can you tell me about something? You're going to take that information and interpret it in some way. Okay, in this, you can shift into an active exercise. You can say, for example, I want to understand, tell me about this API, and it gives you an answer to the API. You can then go look at the source documents, go look at a video that helped generate that response. So you can then sort of say, hey, does this answer sort of legitimate? You could ask a follow-up question. Okay, based on that API, that's not exactly the API I wanted, but now that I saw the answer, tell me about this other API. And it will tell you that API, but also take into account you asked a previous question. And then you can shift active sort of discussion. You can say, can you write me a piece of code showing an example of this API? like then it will come back because the language model itself may know how to use different languages like Java or Python or whatever. It will then write, you can ask it to write it in a particular language, and it will write you a Python script utilizing that API. I mean, if you think about that in terms of traditional search, it's just, it seems like fantastical. It seems like, how could this even exist? It went from individual isolated search elements to, I can now do a conversational search where I can drill down, ask follow-ups, redirect. I can call the sourcing of it because I'm using RAG. And then I can go from passive to active and say, hey, actually create something new for me based on what I just asked about. That makes this amazing in terms of its capabilities.
Yeah, there's one question mark in the chat from Jerry that says, can you tell me more about the right and wrong of information, specifically true false models based on law? So again, that legal example of maybe there's a revision to the source of truth over time. How do you see something like RAG versus like a fine-tuning methodology being helpful in those types of cases?
Yeah, that's a good question, and we're working through some of those issues right now. I mean, to me, a couple of things that I want to use to safeguard this system as we get a better understanding of what's a quality answer from a legal perspective is one, I am a big believer in, showing the work, like no black box answers. I want the answers to be white box. I want to be able to show where this answer came from. So that's why I do think in many cases, depending on the situation, if your data set is a set of documents, then using a RAG style approach, I personally like that much nicer than trying to train or fine tune a language model because again, you lose connections with those documents. And I think the connection to the document is critical as the first line of defense for someone to say, I asked a question, got a response. Can I see where that came from? Can you show me in a couple of seconds, like exactly where that response came from? And I think that's the first place I want to start. The second place is you can do evaluations on responses. And one of the evaluations you can do is something called groundedness. And what groundedness does is it evaluates the response to the original context that was retrieved from that vector store. So you can actually evaluate, hey, this was the response, this was the actual retrieval I did. How related are they? And you can start to determine, did the answer mostly come from the language model, which would make it suspect? Or did it come from the documents, which would mean that it's likely a stronger, higher quality answer? So that kind of evaluation can be done. And you can even build in evaluations in terms of looking at the original question and saying, I did a retrieval. How well was that retrieval to the original question? How well was the answer to the original question? And then, of course, we do have some things going on inside of HPE where we actually have some analysis data where we actually see questions and responses done by actual paralegals. And then we're going to test that against an AI to see how well does it respond in the same question set to an actual human paralegal compared to what the AI generated response is. So all of these are sort of important aspects of sort of safeguarding against hallucinations and just low quality answers that are just sort of not that valuable. I've seen sometimes you ask a question to generative AI and it gives you an obvious answer. Like, I'm like, yeah, I know that. Like, that's not really helping me. But the thing that really makes generative AI different is that the fact that it can be conversational, you can drill down and get deeper into a question. So if the answer is sort of like not that interesting, then you can go deeper. You can do a follow-up. That conversational aspect, I think, is critical. And I think understanding the document source linkages, whether it be videos, documents, PDFs, whatever, understanding the linkages that actually were used to form the answer, and then also being able to do evaluations on that answer to understand its groundedness or its context relevancy or its answer relevancy. I think those are all important sort of aspects to making this work well.
Mm-hmm. And we have just a couple minutes left here. And Mark, I know we wanted to share some key learnings from the developer perspective. So maybe if we pick one here to leave with our audience.
Yeah. So many of you who answered that you're early in your sort of journey here with generative AI or AI in particular, or that you're kind of in the beginning stages of use cases evaluation and doing some work. I am like you. A year ago, had no AI experience and had done a bunch of projects in my life that were around data management, data manipulation work, but these are all around traditional type of databases. And AI was new to me and the entire team that were doing these projects. We all started with deep learning AI. I went through a whole series of courses to learn about particular pieces of technologies, how to do prompt engineering, what RAG means, agent-based prompting, all of these different aspects. We went and took deep learning AI courses to learn them all. Then we started experimenting with all of these things to understand how they work. We used at the beginning these LLM services, Gen AI services that you can just get access to and start paying as you go. They were very easy to start working with. All of the frameworks, whether it be LangChain, Llama Index, all of these things are easy to get access to as well. So it was really easy to start. Now, of course, the way we started meant that you have to be careful what data you choose. We couldn't use any internal private data in our company because we were using services out on the open internet. You can't exchange private data. So we had to make sure we're using public data and doing experimentation with that. But that's how we started. And we just started experimenting with this and started to understand what does it mean to build these kinds of projects and how can we get quality answers. And we did projects around Ask George, a kind of IT ops reduction of time to get to a response. And we also are doing something called Ask Bob, which is a contract legal analysis type system. So that is where we started. The foundation model selection, I think, is an important thing. As you get deeper into this, then I think you'll want to make a smart choice on what the foundation model is. I think early on, if you're early in the journey, I think this doesn't matter that much. Start with something that's easy to access. I think the approach is much more critical. What kind of data are you talking about? Are you talking about live data? You may have to start using like agents to get access to that, and API calls if you're talking and using AI to make those API calls and get live data. Are you talking about data that's sort of static in terms of documents, but it can change over time? Then you're probably looking at a RAG style solution. Or are you looking at static data, like in the case of like an IT ops remediation system? You could have like a bunch of closed trouble tickets. Then you might want to train those into a model because it's sort of a closed data set. So kind of looking at your data set, looking at how you want to use it, then I think you can sort of start. I would suggest that people start with things like RAG. It's the easiest as an engineer with data management experience to kind of start engaging and playing with and start to see how you can sort of take a data set, whether that be, even if it's a video, it doesn't matter if it's a video, PDF, some other type of document, you can generate it into text. That text can be vectorized, and you can start to see what does it mean to do a vector search and to be able to get data out and then hand it to an LLM and get back a natural language response. That's the easiest way to start these types of projects and see how they might fit to a particular use case. As you get deeper into this, you'll understand more about how to up the quality with evaluations and things of that nature to build in things like linkages back to the document, those sorts of things. And then as you get more into this, you'll understand that building your own models can be something you'll do as well. Like, for example, we're building a model that we can look at a document, extract its structure, and determine where it came from, what template built this document. So that will become like a document, a little model we're building to classify documents. So that those aren't difficult to build as you get your knowledge base expanded. Those kinds of models are easy to build generally for smaller models. You can use large models for natural language, and you can just sort of start to build out this journey. And just recognize you can get started very easily with this if you can identify some publicly available data sets that your company has and just start doing experimentation and start working it toward the use cases that you're interested in understanding.
Thank you, Mark. Thank you, all of our panelists. I know we're at the end, so you'll probably see a end of session poll up there. We'll send out an additional email follow-up on some things that you can read if you missed the Discover announcement of this Antonio Nearly, a holograph of Antonio Nero. So it has a deep dive into how that was built and how that interactive chat dialogue was constructed, including the guardrails aspect as well. So just take a look out for that in your email.
Thank you, everyone. I think it might be also good to think about a follow-up session. It seems like we have quite a lot of things that we could continue discussion on. And but for today, thank you very much, everybody in the panelist group, and thank you everyone for joining. Yeah, please answer the end of session poll. That gives us a good input on what you like, what you didn't like again. And we'll talk to you next month, and hopefully we'll see you again, and we'll see you also joining the meetup sessions. Thank you everyone for joining, and have a good rest.
Thank you.